Right angle triangle has these vertices, find the sum of all the possible values of k. So I think a good shout is to try and visualize these different right angle triangles, where the right angles could occur. So if I put it like really high up here, then I've got an obtuse angle here, but as I lower it, at some point, I'm going to get a right angle. Actually, it's our first right angle, that highest value of k up here. Okay, we'll come back to that. If I then lower it a little bit, let me put that back in, I could get a right angle at C. This is point C. Okay, so I've dealt with those two. And then as I lower it again, I'm not going to get any more for a while, like here, because you can see it becomes obtuse at C, so really small at A and B. So now I need to go underneath, and I could get one, again, could I get one at C somehow? It's pretty close to being one, I think. I'm not going to be able to get another one at A, because it'll sort of be down here. But I could get another one at, I could get one at B. So if you can figure out that at the start of this question, you're in a good place. It's good to get, I mean, obviously I've used like pretty accurate diagram here, but still, if you just draw something that and it looks pretty good, and just think about moving up and down the line, you can get pretty far, I'd say. So we're looking for 4 solutions. Now in some work solutions I've seen, they use the gradient, but I decided when I did this question to use Pythagoras' theorem, so I'm going to stick with that. Let's work out length AB first of all. So it's the difference, 2 to 9, so 7 squared plus 4 squared, square rooted. That's root 49 plus 16, root 65. Just add on there. So that is, what is it, AB. Let's do AC. So that's going to be 3 squared plus, it doesn't matter which way around you subtract it because I'm then squaring it, so I'll do the k first. So 9 plus k minus 3 square rooted. So that is here. And then BC, sorry, it's going to be 4 squared plus k minus minus 1, so that's k plus 1 squared, square rooted. Okay, there we go. We've written down the lengths, but with Pythagoras' theorem, we're going to then be squaring them. So for the top one, if I call it 1, then I'm going to have AC squared, so that's 9 plus k minus 3 squared, plus AB squared, that's 65, is going to equal BC squared, so that's 16 plus k plus 1 squared. This is going to take time. Can't really do many shortcuts. Maybe that gradient method is a bit quicker. I don't know. It looked a bit awkward when I saw it, so I didn't even spend much time on it, to be honest. I'm going to get k squared minus 6k plus 18 plus 65 equals 16 plus k squared plus 2k plus 1. So k squareds cancel. I can minus 16 to give 2 here, minus 1 to make it 1. I'm going to get 8k equals 66. So then k is going to equal 66 over 8, which is 33 over 4. So that is that's my first option. Or we got decimals going on there, so that's going to be 8.25 because 32 over 4 is 8. Okay, I put a little box around that one so I don't forget about it. So that was 1. Now let's look at part, sorry, that is C. Let's look at 2. Actually, both of these end up being 2 because they both are right angles at C. So then it's going to be AC squared plus CB squared equals that root 65 squared, so 65. So k squared minus 6k plus 9 plus 25. When I do 9 plus 16 plus k squared plus 2k plus 1 equals 65. That's 2k squared minus 4k plus 35, but then I'm minusing 65, so I'm going to get minus 30 equals 0. Divide by 2. That's k minus 5, k plus 3 equals 0. So k will equal 5. That's this one up here. Or k will equal minus 3. And that leaves us with this final one. So the right angle is now at B. So it's going to be 16 plus k plus 1 squared plus that root 65 squared is equal to AC, which, where's that gone? 9 plus k minus 3 squared. Sorry, I said it was 3, and then I think I labeled it 4 here. Apologies. Okay, I'll call it 3 now because 2 gave us 2 answers. So 81 plus k squared plus 2k plus 1 equals 9 plus k squared minus 6k plus 9. K squareds cancel. I'm going to get 8k equals 18 minus 82. That is going to be 60 minus 64, giving us k equals minus 8. Nice. So to sum them up, that's what we're asked to do. We can sum the minus 8 and the 8.25 to give me just 0.25. Can sum the 5 and the minus 3 to give me 2. And hence our answer is 2.25. Yeah, I really like that question.